Good morning. So, we are looking at performance improvements again today, as much as we can. I've made a couple changes since last time we talked, and the performance is marginally better than it was before. We're still crawling around this pixel display, so we're going to have to do something about that. So let me show you what I did. Basically, the screen is, instead of containing a pixel array, it contains a pixel display and a back buffer. And set up the install and flip methods. There's two screens in the game. If we go over to the game class, you will see when we initialize this thing, we create a screen and we create the light screen. Those are the only two screens we ever make. So I set it up to install the screen that's actually going to be displayed. And that's what's going on here. We just installed display 5, which is where the default pixel display is usually installed. And then we use the scale property on the pixel display to make it big. I modified the scale from 3 to 5.3 to make it match the Mini Micro's screen. And it doesn't quite fill up the width, which I'm going to leave. I'm going to leave that for now. But that would not be that hard to change. We'd probably change this from like 160 to 180 or something like that. But then, when we get down to the render function in our game, you'll see that that whole chunk is gone. So that's one set of nested for loops that we no longer have to execute. We just flip the screen and it's there. So I'm trying to take out as many of those middle steps as possible. We're still not rendering very quickly, but then we're rendering every individual pixel on every single frame. And there's a couple of other bugs. If we go to the menu, or the inventory menu, you'll see that it's empty. There should be 2 items in there. I'm not sure why there's not yet. But the big thing I think we're going to need to do, we need to get away from these pixel displays. They're just not going to have the performance we need. We can optimize certain things about them, but at the end of the day, they're still going to be slow. So what we're going to build today is another test program. What we need to do is dynamically build a tile set that is suitable for using in our TileDisplay. We have a couple of test programs. The main program has a level render in it that we need to split out. So I'm going to go ahead and do that now. No. Oh my god, am I going to do that now? Yes, I did keep a copy of that. I just hate blowing away perfectly good test code, especially since we're going to have to go back to the level generator again soonish. probably just gonna have to come back to this one. I've changed. Oh no, it does work. Tick count not found. And the next thing will be that it can't find the input handler. Anything else is going to get in our way? We're going to come back to this. Okay, the big thing I need to make this work. I'll get that done offline. The big thing we need to work on right now is the tile display. Copy it from our sprite test. So let me think, how do we want to do this? Let's start. Review the wiki again. What does a tile display want? Well, so its own display, we're going to need to allocate one. Display 5 is what we're using now for everything. We're going to keep the sprites on that layer, so let's put the tiles on display 6. Tile size is 8. Columns and rows on screen. Well, I guess I'm not sure. Columns, rows, we'll do that. We'll just start with this test code. Yeah, let's just run it. We'll see what comes up. And trying to figure out why it's not doing anything. We got the line 173. I think it's not doing anything because we just can't see it. set. All these cells are filled with something. Let's use display 5 just in case it's including what we can see. Yep, that's what was happening. So, it's able to use our tile set to render the tiles. The problem is they're all black and white, except for those purple empties. So we're going to have to basically generate a new tile set on the fly. And it's going to need to be something that, like, as we load these tiles, it needs to allocate whatever colors it needs and then load them into the tile set. Which feels tricky, but I think we can make this work. Let's pick on one of these tiles. We'll look again at how it works. Just the rendering bits. So the grass tile, just looking at this one, it has a couple of colors it uses. Each level has its own grass color. And then there's a transition color going between grass and whatever it's next to. So. And it can use a lot of different tiles depending on exactly where it's located. Because it's not just these, it's these top 4 up here. But then it's also picking on either this side or the one next to it to handle the transition between tile types. Tile set is just the image. Let's make a new image. Can we make a new image? No, we can make a new pixel display and pull the image out of it. And it looks like we can change the size via the clear method. 256 by 256. I don't know. I mean, we want to keep tacking tiles onto the end. Then what we might want to do is make the width 256 and the height 8. Yeah, 1024 by 8. Because 1024, that holds, what is 1024 divided by 8? That'll hold 128 tiles. Which is, that's the same number of tiles that we had before? No. We were previously holding 1024 tiles on the icons PNG file. If we wanted the equivalent, but all in a row, we need to have a really huge width. Like 8 times that. $8,192 divided by 8, 1024, so that's a whole mess of tiles. And then we need to figure out how to render something from that icons PNG file onto the tile generator display using the color set for the grass. Our screen class has something that can help us there. Create our generate tile function. Tiles is 0, which means the x offset will be 0. We are going to generate a tile, we need the tile sheet, the tile index, the colors, and the bits for flipping the thing, if we're going to be flipping it. So we actually do need that sprite sheet. I'm just going to make that function on the off of the display. Hopefully that's okay. YP will always be 0 because the tiles are in one big long row. So if I did that right, let's try generating a tile. We need the tile index. Well, we need the sprite sheet. We need the tile index, we need the colors. Going back to grass tile, we actually need that color. And we're going to leave the bits at 0, like that. Make that the default parameter, the default value. And that should, we need the image there, so tile generator display, get image. That should give us one grassy looking grass tile, clear to 0, and everything else should just be orange. Let's see if it works. Sheet not found. What'd I forget? Oh. Anything else here? Let's try that again. So that's encouraging. We can generate the grass tile. So what we need to do after generating the tile, num tiles plus equals 1. Return the previous tile. So that will generate one tile, and then return the tile index. And then I wonder if we can find a way to integrate this idea into the game like one tile at a time. Just to see if it's working. I actually don't know if that's a thing. How many grass colors do we have? Only the one. Okay, that makes it simpler. Okay. I'm going to rearrange this a bit, I think. Think about how I want to do this. We're going to have to make use of the TileDisplay's scrolling parameters to get it to work right, which means we also need our PixelDisplay to properly use those scrolling parameters. Right now it's using this custom X offset and Y offset. Let's change that. PixelDisplay has scroll X and scroll Y properties. Like this, it's on the screen, but it also needs to be mirrored into the display in the back buffer. I think we will do that down here. Yeah, that should work for that. And then let's see where else those offsets are being used. Theoretically, we should no longer need to manually subtract these. It should just work. Let's see if it does. There's always something I miss. I might have to invert the offsets. If everything scrolls in the wrong direction, then the solution will probably be to invert them in the set offset function. Whoa. So that's kind of special. Yeah, it's just not working at all, is it? Alright, so what went wrong? I kind of thought that would just work. I had some hope of it just working. Get a set horizontal shift applied to the entire display. Shouldn't have screwed up the title screen. That should have just been zeroed out. those lines. Let's see. So that shouldn't have screwed up the menu. Well, that's weird. I don't feel like we made enough changes for it to be messing up that bad. Trying to see if there's anything else I missed here. Okay. Back where we started. So that experiment didn't work out very well. We're going to try it again. No, we're at a half hour. We've been at this for a while. We have the preliminary steps for this tile generator working, and we're going to cut it off there. There's still a lot of work ahead of us. We need to figure out a way to get the scrolling to work. We're not going to do that right now. But once we do that, we can start doing a bit of work to integrate a tile display with the pixel display. So that will probably be interesting. We still have a lot of work in front of us, getting the performance up to where we can really make this into a playable game. And that is where we are going to stop today. So thank you for joining me, and hope you can join me next time. See you later.